In this video, I'm going to show you how to use a software-defined radio to scan for railroad telemetry signals and then decode them using the tool SoftEOT and SoftDPU. Unfortunately, there are no trains going by my area right at the moment due to some work blocks, so you're going to have to trust me that this setup works, but I know that it does, and it should be helpful to those of you who have been trying to figure this out. Alright, so overview of what it is we're trying to do here. If you go to radioreference.com, they have a listing of all the railroad frequencies in your area. Frequencies that if you use a scanner to listen to the crew chatter on a train, you're probably already aware of these various frequencies. For example, I live by the Canadian National, the Waukesha subdivision, so if I was to listen to the railroad chatter, I would want to tune my radio to that frequency to hear what the crew is saying. However, that's not really what we're interested in right here, right now. What we're interested in is the radio telemetry and data that's being emitted by the trains themselves. Those of you that are veteran rail fans already know about this. The FRED, or the rear end device on the train, emits a signal, emits a little bit of a chirp that you can hear with your radio. And if you're hearing that chirp, you know that there's a train in the area. Similarly, the lead locomotive, or the head of train, also emits a chirp, as do the DPUs, or distributed power units. So if you're using an actual hardware radio and you program in these 6 frequencies, and then you have your scanner loop through them while you're trackside, if you start to hear chirps in one of those frequencies, you know that some kind of train is nearby. So what we're going to do here is we're going to use a software-defined radio to listen to these same frequencies, only we're actually going to decode the frequencies to see what information they contain, more than just a little bit of noise that says, hey, there's a train nearby. So it is a nice website, this radio reference, and I would suggest bookmarking it because we're going to need to know these 6 frequencies for what we're doing here. So a little visual overview of what we're attempting to do. We're going to use a software-defined dongle, or a USB dongle that I have plugged into my laptop already. In my case, I'm using a dongle product called RTL SDR Blog 4. It's a relatively inexpensive software-defined radio at about $40-ish on Amazon, and it seems to get the job done here. So we're going to have that dongle plugged into the laptop. We're going to use a program called SDR Sharp to actually do the decoding of the railroad frequencies. And so what I've got diagrammed here is that we're going to program SDR Sharp to know about the end of train, head of train, and DPU frequencies, and we're going to use a plugin called the Frequency Manager plus Scanner to scan through the various frequencies waiting to hear something. And then once the Frequency Manager plus Scanner hears something, like a DPU1 chirp, it'll stop, and that information will get decoded by the SoftDPU application. And the SoftDPU application has the ability to log to either binary or a text file. I'm preferring to log to a text file for various reasons. But similarly, if the frequency scanner chooses to, or it happens to stop on the EOT or HOT frequency, it's actually the SoftEOT application that would decode that information and then log to a log file. As you'll see shortly, the information available in the chirps from the HOT and EOT are considerably different than what comes from a DPU. The DPU, being an actual locomotive, is able to provide a lot more information to the head of the train than the simple end of train device would. Nonetheless, it's all interesting information. So, in addition to purchasing this SDR, which I'll show you the link to that in a minute, what software do you actually need and where do you get it? In order to download the SoftEOT and SoftDPU applications, you have to go to groups.io and I don't know what /g/SoftEOT and become a member of the SoftEOT group. I don't recall that it takes very long to get membership, but you need to get membership before you can actually download the files. And I believe it's under the files directory, software. You would want to download both of these zip files and extract them. So that's where you get your SoftDPU from. There are no installers for these applications, and I'll show you shortly where I put the executable files to keep things organized. So the next thing you will need is to download an actual application to run your SDR dongle, or actually show the output of it. I chose AirSpy or AirSpy's SDR Sharp application because it's the only or one of the very few SDR applications that I'm aware of that has scanning built in. Scanning meaning the ability to switch from one frequency to another very quickly, and to listen to hear something, and then it'll stop on that particular frequency and listen to whatever information is available. A lot of the SDR software doesn't have that scanning ability built in, which I find weird because hardware scanners typically all can do this, but software scanners typically can't. So anyway, I do believe I have this first package downloaded. Revision 1921 is what my computer shows me. I do have the ability to do 64-bit on my computer, but I had issues with getting the 64-bit version to run with the plugin that actually does the scanning. I think the plugin is probably pretty old, and so it's a safe bet to just start out here with this first download and run that, and away you go. Another thing you'll need are what is called a virtual audio cable. What this does is it allows a program like SDR Sharp to take its audio output, which is going to be the noise and the chirps created by the trains themselves, and you can pipe that output from SDR Sharp to the input of SoftDPU. So it's essentially like literally a patch cord that you might have in the real life, only it's for your computer. I chose to purchase this virtual audio cable. This version's not free. I think it's like 30 some odd dollars. And the reason why is you can create an unlimited number of patch cables or virtual audio cables with this particular software. However, if you don't intend to create more than one virtual audio cable and you don't really want to spend the money, you can also use this version by VB Audio. I've tried this as well. It works just fine. You are limited to one virtual audio cable, and that's really all you need for the setup we're using right here. So if you're just trying this out and don't really want to invest too much money, perhaps use this one. Installing either of these is a bit beyond the scope of this video, but you do need the virtual audio cables installed. And finally, where do you get this software-defined radio? The one I happen to be using is from RTLSDR.com. If you go to the store, it shows you, basically it'll take you to an Amazon link, I think. Somewhere in the bottom, yeah. This is the particular package I purchased. It actually comes with a real cheap antenna and the radio, and well, here right now it's between $40 and $50 for this full package. If you actually have antennas, you can get it a little cheaper. And I don't even know if you particularly need this brand of SDR. It's just the one I'm using. There are other low-priced SDRs that might do the job just fine. But this is the one I'm using, this version 4, which is the latest version. Alright, so next up, let's go to where and how I organize these various programs on my hard drive. And so this is Windows 11. which Microsoft is pretty much forcing everybody to Windows 11. So hopefully this is what you're on as well. In Windows Explorer, on my local drive, right in the root of the local drive, my C drive, I create a folder called Train Detection. I do not put things in the program files folder because you normally need administrative rights to do anything in these folders. And I've had issues with applications that don't have installers, like ATCS Monitor, for example, where if you install them into the program files folder, certain things just don't work because you need an elevated permission to even run the program. So by putting things outside of the program files folder in a custom folder, you'll likely not have those issues with your user permissions. And you won't necessarily need to be an administrator to do anything. So under train detection, I have a folder for each of the applications that I just showed you. For example, here is my SDR Sharp folder. Here is my SoftDPU folder. And here is my SoftEOT folder. So it's really just these three applications that we're going to be running. I'm also doing some trickery with a program called AutoHotkey. AutoHotkey automates how you can open windows and things like that on a computer, and so I created some scripts in here that will actually launch SDR Sharp and SoftDPU and SoftEOT for me with one click, because I find it kind of annoying to have to click on all these different things just to get the scanner running. But once again, this is kind of outside the scope of this video as well, because this took quite a bit of time to get this configured, but it's out there. And we're not going to be using Spy Server. That's outside the scope of this video. But some things that are probably relevant is that I created a logs file here outside of SoftDPU and SoftEOT, because these two programs do output a log, and I wanted the logs to go to one place. I didn't want them nested underneath these folders. And so I have this logs folder here, and as you can see, I'm logging either SoftEOT or DPU logs to this folder, and this allows me to run a file watcher to watch for these logs and then do things with the information provided by them. Alright, and so in each of these folders is pretty much just the downloads that you would have downloaded from the previous section of the video, and you'll unzip the download files and unzip them to a folder like this. And so it just contains a ton of files. With SDR Sharp, I happen to be running this version of it, the .NET 9 version. However, you don't get a shortcut because there's no installer. You won't get a shortcut to your start menu like you might want. And so what I did is I right-clicked on the executable and I went to show more options. And then why Windows 11 makes this such a pain, I don't know. And then I went to create shortcut. And that would create a Windows shortcut, kind of like this one, where I renamed this a little bit. I got rid of the .NET 9 part of it. But anyway, this is a shortcut. And so with that shortcut, you can now right-click on it. And you should see an option to pin to start. And because I already have it pinned to start, my option here says unpin from start. But anyway, you should be able to click pin to start, and then that will give you the option, or that will give you the shortcut in your start menu in Windows 11. Beyond that, I didn't really change anything here. So very similarly with SoftDPU, you would want to create a shortcut from SoftDPU, right click on it, go show more options, create a shortcut. A shortcut would land here, right click on it, pin to start. Actually, you might be able to just pin to start right from here without the shortcut. I don't recall. I guess that'll be up for you to figure out. And as you can see, there's no log files or anything in this folder because that's not where I'm logging to. Same thing with SoftDPU. Well, that was SoftDPU, and here's SoftEOT. Looks very similar. No log files. something to note, the INI file that gets generated by the application is basically the configuration file for the application. So once the application runs and as you are toggling the various settings that you want, what the application is really doing is just writing those settings to this INI file, which is just a text file. So if you look over here on the right, you can see some of the information that would kind of make sense for how this, or how SoftEOT is configured on my machine. So for the initial logging directory, you can see that I have it logging to that folder I showed you earlier, the logs folder in C:\trains detection. Similarly, when I was running, or when I am running SoftEOT and SoftDPU locally, I actually do have it set up to create a sound. So whenever it detects a new train movement, it would play a sound, which actually the sound is listed right down here. So that's kind of nice. If I have this process running in the background, every once in a while I hear this little ring wave, a little chirp, and that tells me that, hey, SoftEOT is detected there's a train in the area, a new one that it hasn't seen before, and then I can go look at open up SoftEOT and kind of inspect the data. That way I don't have to just sit there and stare at the screen all the time. But anyway, as you can see, you can actually modify this file by hand if you would like, rather than using the executable to set up some of the defaults that you would like for your machine. So that being said, that's not supposed to be open. All right. So next up, we'll start with SDR Sharp, configuring it, getting it ready to go. So for now, I'm going to just, instead of using my auto hotkey shortcut, I'm going to use SDR Sharp shortcut. All right. So I'm not an expert at using SDRs or radios or any of that. And so if you see something in here that could be improved upon or done better, let me know in the comments below. But this setup seems to be working for me, so I'm going to run with it. All right, so the first thing you want to do is tell SDR Sharp what radio are you using. I happen to have two, not necessarily connected to my computer at the same time, but I do have two. So you want to go to source, and in this case RTL SDR USB. And now when you actually purchase this dongle and install it, I believe there actually is something like a driver you have to install in most cases, which once again is outside the scope of this video. But if for whatever reason you click here and you don't, or SDR Sharp doesn't find your dongle, your SDR dongle, you probably didn't install it correctly. Nonetheless, you want to select that radio so SDR Sharp is aware of what radio it's going to use. And where that'll show up is in the Sources tab. And so under Devices, like in my case, my dongle shows up as this generic RTL blah blah blah. And I only have one. You could actually have multiple, but I only have one, so it's the only one to pick. Sample rate, quite frankly, I don't know if there's any benefit to going to a lower sample rate. There might be. It might speed things up. I don't know. I have it maxed out at 3.2, whatever MSPS stands for. Once again, if somebody knows better than I, maybe it's a different sample rate would be better. Same thing with the sampling mode. I don't really know the difference between the different modes, and so I just selected the one that is the default. All the other settings I have pretty much turned off because I don't think they're really relevant to what we're doing here. And in terms of gain, that would be the one thing you do want to adjust. It's my understanding that with the gain, it's kind of like amplifying the signal through software. And I'm not quite sure what the difference is between using the actual volume slider in the RF gain. If you can turn one or the other off. For whatever reason, I just happen to have my radio set to 11, even though I'm not going to hear the output. And I happen to have my gain set at 37 decibels because that seems to be working for me where I live and how close I am to the railroad tracks. It's my understanding that you would actually really want to have the gain set as low as possible, because the higher the gain, the more distortion that can be caused by your actual software in your own radio. In addition, if you crank the gain up too high and you leave it that way, it's my understanding you can overheat your SDR dongle itself. The electronics in there get really warm, and if you're trying to make it do too much, you can overheat it and essentially wreck it internally. So don't just crank up the gains all the way to the max level just to hopefully hear the most things. That's not really how it's going to work. You actually want to have the lowest gain you can get. And so this is something you'll have to play with on your own to see what works for your situation. I do actually have to have a shift enabled, and we'll see that shortly. What you find with the inexpensive dongles like the RTL SDR Blog 4 is that they're not precision machines. And so even though I might program in a frequency like 452, 925, the reality is the dongle is kind of not really listening on that frequency. Its electronics are off a little bit. And so you can compensate for that by this shift value. You can either go a little bit negative or a little bit positive to actually correct the inaccuracies of your dongle. So once again, you don't need it set here, but I will show you where you can set that value. The other thing that's somewhat important is under the radio tab. Once again, we're not actually going to use these settings here for scanning, but what I do find is that for detecting end of train and DPU frequencies, we can pretty much stick in the narrow FM bandwidth. And I find that for HOT and EOT frequencies, something around 15,000, a bandwidth of 15,000 is pretty good. For DPUs, I was going to 20. It seemed to work for me. You don't want to go too wide of a bandwidth, because then your radio is trying to listen to too much stuff, and then any kind of static or other radio transmissions might get well, your radio might pick up other radio transmissions that you don't want to, causing some noise, which will then result in your SoftEOT and SoftDPU not actually decoding what you're hearing. So anyway, these are the simple settings that I'm aware of that you might want to consider. And kind of going back to I forgot one, audio. This is where you tell SDR Sharp to put its output, like which audio device is going to receive the output from this application. And so going back to the idea that you need to have virtual audio cables installed, this is where you would select the virtual audio cable as your output. I'm choosing line 1. As you can see, I've got a ton of different things on my computer, or at least options, but I'm choosing my virtual audio cable line 1 to be my output here. And this will also be the input that I choose in SoftDPU and SoftEOT. I don't really know what the latency is for. I think it defaulted to 50, so I left it there. Same with panning. I didn't touch this, just left it where it is. If there's a reason why I should, let me know in the comments below. All right, so what we're really interested in is this thing over here called the Frequency Manager Plus Scanner. This is a plugin to SDR Sharp, and it's not a great plugin, but it's all we've got. And it is the thing that actually will do the scanning for us. And this might not be enabled by default, but even if it is included in your installation, and so what you'll need to do is go over to this hamburger menu and go down here to the very bottom to Frequency Manager and click on that. Or actually, it might be this one. Yeah, it's actually this one, Frequency Manager Plus Scanner. Because the Frequency Manager that's built into SDR Sharp, it isn't used, which is kind of a bummer because it's a little more intuitive, but it's not used. And so as you can see over here, I actually have that Frequency Manager kind of pushed off to the side because, well, it isn't used. But I do have the Frequency Manager Plus Scanner highlighted. So what we're going to do is we're going to create a scanner group. Well, actually, I already have a scanner group, and that'll be what you need to do as well. You'll have a scanner group, and in that group are the 6 frequencies that you'll expect the scanner to scan through. And this is where things get weird. I don't like the interface for this, but you have to deal with what you have to deal with. If I go to the Browse button, you can see that I have the 6 frequencies we're looking for set up, and I have them set up in a somewhere. Oh, here it should show all of them. All of them are in the same group called Telemetry. There's not a lot of customization that happened here. These are the frequencies that I showed you on radio reference. I don't know what the difference would be between the frequency and the center. I just have them all centered at their exact frequency. I have a description for each one that makes sense. Once again, the mode is narrow FM. Here is where the -4 shift comes into play for my SDR dongle. That value of -4 seems to work for me. For my SDR dongle, might need to be different for you. In terms of filter type, this is the default. I don't know if there would be a different filter type that would be better. And here in terms of filter bandwidth, that was the bandwidth that was displayed right here. Once again, I went with 20,000 for the DPU settings and 15 for the HOT and EOT. Your settings might vary. I didn't change this filter order. I don't think it matters. You do not want squelch enabled because we are not listening to audio, we are listening to data. And if you crank up the squelch, you might actually be covering up some of the data that comes through in the chirps. So kind of ignore that setting. This, I don't even know what the CW shift is for. Same with step size. Yeah, pretty much everything else here except for the group itself is a default. I didn't change it. So you'll want to have all 6 of these set up in, once again, a group. Actually, I don't even think this is where you add the filters. This is just editing them all at once. I don't even remember how to necessarily add one. Maybe go to edit. So I think what I did is I went up here, I added a frequency, made sure it kind of worked. Then I went to edit and tweaked the various settings how I wanted them, and then added them to the group I wanted, and then clicked add. So, not very intuitive that you're in the edit screen, but that's actually where you add a frequency. And in fact, I don't even remember how to create a group. Somehow I created a group clicking on something, and it showed up here, here to click on. So good luck with that. So cancel that. All right, so by default, under scanner, it'll probably be set here to scan a range. That's not the feature we plan on using. We want to scan the group that we selected or we created. And I would recommend you only create one group, because if you have multiple groups here, SDR Sharp has a tendency to default to whatever the group is with the name that starts with the letter that's alphabetically arranged. So if I had a group called A stuff, it would be the first group selected, even though that's not the one that I want to scan. I want to scan telemetry. By only having one group, this is always the default group. All right, so we have scan a group, and we're about ready to roll here. Okay, so one other thing I did is if I zoom in a little bit on whatever this top graph represents, you can see some colors up here. And it happens to be showing, when I highlight them, like what frequency that represents and what the bandwidth is. Now, that is actually showing up because I have the 6 telemetry frequencies in Frequency Manager for SDR Sharp, and I told SDR Sharp, hey, display these frequencies. These colors are not because of Frequency Manager, and quite frankly, they're not all that useful. When the program is scanning, it's just going back and forth, back and forth. But I just kind of like it that it creates these blue bars that when the waterfall kicks in, you can kind of see that if something is off to the left or off to the right, that pretty much means it was a DPU just gave us a chirp. And if it's in the center, it was probably either the head of train or end of train. But once again, because the scanning is going back and forth, even the waterfall is not going to be all that useful because we're not fixed on any particular frequency, and so you'll only see like a little snippet of what the waterfall would be, and then the scanner might move on to something else. So this whole UI isn't super useful once scanning happens, but it is useful for tweaking your frequencies to set up scanning. All right, all that to be said, let's get this thing running. What does it look like when this thing is actually scanning? So you'll just hit click scan once you've got your telemetry group set up and let it rip. And once again, I apologize, there's no trains in the area, and choreographing this video with when there might be a train in the area is darn near impossible. So trust me that this works, or it should work. So how do you know that this is scanning? Well, you know it's scanning because you can see up here this thing's going bonkers. It's because it's switching back and forth between the different frequencies looking for something. And a fatal mistake I made was that, see this little yellow bar here? That is represented by the minimum signal strength setting. If you don't set that correctly, if it's set too low, what ends up happening is the scanning doesn't scan because it starts picking up all this static. And so you want to make sure that that bar is set high enough that the scanner doesn't stop anytime some static happens. So I'll show you what I mean here. If I start adjusting the down arrow and lowering that bar into the static, see how it's shifting all over the place? And if you get too low, ironically, it's still shifting all over the place. But it's not really even listening for trains anymore. It's listening to whatever this garbage is down here. And it's doing it very quickly. And so I had that bar adjusted way too low, and I was like, I don't think this is working. I don't think scanning is working. And the reality is, it was working just fine. It was just working too well. So what you want to do is you want to adjust the little yellow bar to go above the noise. And see how it kind of calms down. And so you can see something over here. I don't know what frequency this is. Okay, 457. So something near me is making noise, and this is the reason why you want to make sure your bandwidth is as narrow as possible, because if your bandwidth is too wide, you might start picking up other things, like other radio frequencies that are close to the radio telemetry frequencies. So keep your bandwidths narrow, keep your minimum signal strength above the noise. So unfortunately I can't show it here, but what you'll see is when the train comes and let's say there's a DPU chirp, you'll see like this giant bubble happen in this chart. It'll go well above this minimum signal strength, and then the scanner will hopefully stop there and try and decode, or at least it won't decode anything. It'll send the message through your audio channel through your line out, and then it'll be SoftDPU or SoftEOT that will do the decoding. Anyway, this is where you want to be if you want to be scanning in SDR Sharp. And what I found is that if you get everything set up the way you want it and then you close SDR Sharp, hopefully most of the settings that you set are still there when you open it up again. However, it might not select scan a group. That might be defaulted to scan a range again, which is highly annoying. So when you open up SDR Sharp, you might have to remember to go to scan a group, select your group, and hit start again manually in order to start scanning. Another thing that's a little wonky is if I hit stop here, as you can tell, it doesn't stop. I think what it does is it just keeps scanning on whatever the last frequency was that it left off at. So if you truly want to stop it, you actually have to go over here and stop it. So there, we stopped scanning. All right, next up, SoftEOT and SoftDPU. I'm going to launch them both. SoftDPU. And similar to what I just mentioned with SDR Sharp, these two applications have a tendency to remember where you left off. So if you set this up how you want it, and then you close it, SoftEOT and SoftDPU somewhat remember your last setup. And so try to avoid moving things around too much, because if you move things around and then you close the window, that's where SoftEOT and SoftDPU is going to restart, which might not be where you want it. All right, so starting with SoftEOT, I'm going to assume a little bit that you understand what these applications are for. This is just a setup video and not really explaining a deep dive. What I like to do is I like to have the movements window open under tool movements, because that kind of summarizes that, hey, there's actually a new train coming, and not so I don't have to follow through all the actual decoded packages, yeah, to figure out if there's a new train or not. So the movements window kind of does a nice summary for you. Let's see, in terms of packets, I always like to have size column to headers and data clicked, because that way as the information is coming through, these column headers automatically get wide enough to see the data. Let's see, assign so much, nothing to change there. All right, so that, as you can see, it's already monitoring. And that's kind of something you want to pay attention to. In the lower left, it says monitoring and logging. Monitoring and logging. So both of these by default start up to be monitoring. Well, this one's not logging because I haven't enabled that here. But if you're wondering why something's not working, well, you want to look here. Like, is this thing even monitoring? If it's not, well, there's your problem. So once again, to enable that, if you go into File, Options, this is where you can set everything up. This is how I have everything set up. First thing you want to do is you want to select your virtual audio cable. Once again, for me, it's line 1, and it might be for you as well. That's the one whatever is output from SDR Sharp is input to SoftEOT and SoftDPU. In terms of the channels, I'm just doing mono. I think you can actually do left or right and like get fancy, but I'm sending a different signal through the left channel than the right channel. I don't have any reason to do that, so I didn't. I didn't want to play a sound every time there's a valid packet, because that would drive me bonkers, especially when there's actually are trains in the area. However, I did want to play a sound when there's a new movement, because this is the actual indicator of a new train in the area. Every time there's a valid packet, you could get 30 packets from the same train, and so that's not really useful, at least not to me. And so once again, if you look at the path here, see train detection sounds. That's why I created that sounds folder right here. So there's kind of a generic place for both SoftDPU and SoftEOT to go get whatever sound files I want to use with the applications. And so I checked that checkbox. Packet types, I'm listening for both EOT and HOT because we're scanning. Auto scroll, that's more for this user interface where it'll automatically scroll to the bottom of the list to show you the latest packet that it received. I'm getting old, so I bumped up the font size a little bit. I chose the dark color scheme. I am in America, so I'm using US units. Oh, and here is where I want to start monitoring when the program starts. And thankfully, this program, SoftEOT, has the ability to automatically start logging to a text file on startup. And so once again, here's my generic logs folder where I'm automatically going to dump a log to. And what happens is SoftEOT creates a new log every day with the date timestamp in the name of the log. You might actually choose to check this as well. What will happen is the program won't open up like it does here full screen. It'll actually close, and there will just be a little icon in your taskbar. If you aren't necessarily just looking at the application and you're just depending on the sound the sound to tell you if a train's in the area, you might want to use this. This whole section is now dead. ATS monitor, unfortunately, at least in my area, doesn't exist anymore, so ignore that. So once again, you want to click apply here and OK. And then you'll likely want to close this window and open it up again just to make sure all your settings stuck. Because nothing's more annoying than creating all the settings and forgetting to hit click apply, or they just don't save and then something doesn't work because you think the setting is set and it's not. So my settings for SoftDPU are very similar. However, kind of an annoyance is that SoftDPU doesn't have the ability to log to a text file by default. I don't know why the original developer chose to do that. I dream of the day when he adds that option back in, or in period, but that's not here, so that's a little frustrating, which means we have to manually go and enable text logging. But other than that, virtual audio cable, mono, play a sound when there's a new movement, auto scroll. I chose to display invalid packets, and what that does is if a DPU alert comes through and SoftDPU picks it up but it can't decode it, it'll still show you in the output a row that says INV, which is like invalid. But as far as I'm concerned, that still means there's a train in the area. So if my goal is to just know if there's a train in the area, even the invalid packets are useful. What could happen is that, okay, the train is really far away, and SoftDPU recognizes that, yes, this is definitely a DPU packet, but it's a little distorted or some of the information is not quite right, so I really can't decode this thing. So I'll put an invalid message into the display. So as the train gets closer, those invalids might go away and become actual decoded packets. But so for my purposes, I like to see the invalid packets. Once again, apply OK, and then close that window, close this window. Make sure that when you reopen it, all those settings are what you expect. So another thing that I found very important for troubleshooting whether or not this is even going to work. Let's go back here to, we'll start up the scanning. And once again, we are on line 1. And now we'll go back to SoftEOT and SoftDPU. You'll want to open up these, I believe it's this audio level meter. And now this is goofy. It just kind of shows up wherever it wants to. And for whatever reason, I can't move it. I don't know if that's by design or what the deal is, but that's really weird. And similarly with SoftDPU, I want to look at my audio meter. And now see how these audio levels are, well, this is the one we care about, the continuous level. The fact that there's a big blue bar here tells me that it's SoftEOT and SoftDPU are actually hearing the audio output from SDR Sharp. So let's stop SDR Sharp and see what happens. All right, so now we go back here and audio level, back here, audio level. Notice how there's nothing, and it's because it's not listening to anything. Even though it says monitoring, it's not hearing anything. And so this is kind of an indicator to you that if you're having problems getting these two tools to work, you probably have an audio problem. Maybe you selected the wrong virtual audio cable. Maybe you need to just adjust volume settings somewhere in Windows. I'm not going to lie, this is kind of a pain in the butt to figure out how to get it right. But if it's not right, if you're not seeing at least like a 50% blue bar here, or even just a quarter, there's some communication problem between SDR Sharp and these two applications. So once again, I'm going to turn this back on and get my, go this way. Yeah. All right, so we're back in business. Things are listening, and away we go. All right, so that was a very long-winded explanation of how to use an SDR dongle to decode train telepathy, telemetry. uh, it works pretty neat. I'm thankful for these tools that can tell you what the train is doing. Hopefully you have success with your own setup. And if you have any questions, post them in the chat below, and as well as improvements. Once again, I'm not an expert here. This is just me fumbling around trying to figure out how to do this because I find it interesting. But if you are a ham radio expert or an SDR expert and you know how I can tweak something for better performance to hear more trains, let me know. Anyway, thank you for listening.